So apparently this is going to be a three-part series here, but this one won't be too long because I'm almost done. Okay, so we were talking about the post-hoc analysis, and it dawned on me that I wasn't going to be able to squeeze it into part two. All right, so let's see if we can't back up here. Okay, so let's suppose that a carnival operator is interested in whether the season is a factor in the mean amount of money couples spend at the carnival. Okay, once again, a practical application for something like this. Those of you who may be in some kind of business of your own, or you're in the sales or something like that, hopefully you're beginning to see the relevance of a technique like this for you. Okay, once again, our null hypothesis, right, would be that there's no difference between seasons, right? That you're going to make basically about the same amount of money regardless of the season. Okay, the alternative is, hey, this revenue is going to differ at least between two of these seasons. And so, in order to do this study, right, we get receipts from random selected couples from each of the seasons. Okay. So, looks like a job for ANOVA. So we run our ANOVA. Okay, see that p-value? It is definitely less than 0.05, which lets us know that we have a significant F ratio, okay, or F statistic. So we're going to reject the null, right? The null says that there's no difference. We're going to accept the alternative hypothesis that, hey, there is a difference in the amount of receipts, if you will, or we'll call it what it is, amount of money, right, that is being made with regard to these seasons here. Okay, so practically speaking, there's a statistically significant evidence to conclude that season is a factor in average receipts. Okay, so that's as far as this ANOVA test will take us. But if you're in business, you really want to know the next question, and that is, so what season, is the season? To make sure that we are definitely doing our carnival in, or what season is the season to avoid? Okay, and where that cutoff is. Okay, so uh, and so this last point has to do with some of these assumptions here, right? The standard errors are basically nearly equal, which means that, hey, we've kind of met some of those assumptions, which now gives us permission to move on and do this post-hoc analysis. So this Tukey test, and let's just call it Tukey test or Tukey HSD test. There's also something called a Tukey LSD test. Actually lots of Tukey tests out there. So, all right. So if you recall, you can do the Tukey test using either a significance, and so what you would get is output that would actually use p-values, and you could just apply the same point. Thought I'd do it a little bit differently this time and show you how you would do it with the confidence intervals. Remember, the rule about confidence intervals is if zero is in the if zero is in the range, right, then the difference is not significant. Okay, but if zero is not in the range, right, then the difference is significant. Okay, and so the way this Tukey situation works, okay, is and by the way, the way that you generally know that is if it's kind of the same sign or not. Okay, so generally notice that all of these confidence intervals are positive, which means that zero is not going to fall anywhere between them. Okay, which means that if we say compare winter with spring, right, we get that confidence interval, winter with summer, winter with fall, right? There appears to be a significant difference, right? Winter receipts are significantly lower than the spring, summer, and fall, right? So all of those differences are significant, okay? If we look at, say, comparing spring, right, notice that the confidence interval here, does involve zeros, okay? Because this runs from negative 0.99, right? And of course, it's going to run to 0, and then it's gone over 14. So when we compare spring with summer, there does not appear to be a significant difference. Once again, I know that because there's a 0 in between here. And same thing with spring and fall, okay? There's a 0 in between here. So in that sense, the mean receipts in spring seem to be basically about the same as the mean receipts in summer and fall, at least from a statistical standpoint. Okay, and then when we compare summer with fall, okay, notice that they're both negative, which means that 0 actually doesn't fall between them. Okay, and it doesn't really matter if they're both positive or both negative. The point is that 0 doesn't fall in between there. So actually, this would suggest that the mean receipts in summer are greater than the fall. Okay, and so this helps us to identify where the differences are, right? Now I know not just that I had a significant F ratio, but now I know that winter is substantially lower than either spring, summer, and fall. Spring doesn't seem to differ all that much from summer or fall, but summer definitely differs from fall. Okay, so just in terms of deducing from these results, right, I could be pretty sure that, hey, you know, spring and summer is definitely the time in which you want to, make all this happen. Okay, fall, winter, not going to be your moneymaker there. And of course, hopefully this makes sense to you if you go to carnivals. Okay, so just a way of sort of visualizing them. Sometimes what you can do is you can tell the program to kind of put things in order here. So in this sense, you're getting kind of a winter to spring, summer, and fall, spring to summer and fall, summer to fall. And I mean, some of this is just a retelling of what we just said here. Okay, so folks, so that's basically it for chapter 11. Happy reading. I've given you really the nuts and bolts of what it is that you need to know. There may be a ton of other information in there. And so honestly, if I haven't covered it in this presentation, it probably isn't as important. It's probably provided to just kind of help you make the case. Okay? So have a great week. I'm always here if you need me. Take care.